All right, everybody, welcome to Dave Cooper Live, where we bring you the people, the products, and the processes, helping us all to build it better. And today we ask, what's fueling Frank the printer? Also, we have some amazing breaking news. The number one home builder in America has yet again made another move with a company that we showcased at the Startup Zone at the International Builders Show 2024. This time, they chose Apis Core. Founded in 2016 by Nick and Anna, Apis Core is an American technology corporation headquartered in Melbourne, Florida, that develops advanced technologies and materials for construction using 3D printing technology. And no, this is not the gantry machines that you've been seeing. You can deliver this with a pickup truck and print a house. Yeah, not kidding there whatsoever. But first, before we get into any of this conversation, we got to thank our sponsors because we cannot continue to deliver all of these innovative conversations without them. So take a few minutes and say thank you. Stream Modular, the only logistics company you need to transport your mods, pods, and panels. Our friends at Stream Modular are investing $50 million over the next 25 years to build the technology, solutions, and trailers needed to handle and transport the projects of today and meet the demands of tomorrow. Reach out to their team at streammodular.com to discuss your next project. CombiLift is the largest global manufacturer of multi-directional forklifts and straddle carriers, a leader in long load handling solutions, offering a free warehouse and site optimization design service. CombiLift helps companies of all sizes and from every industry maximize the capacity, safety, and efficiency of their warehouse and storage facilities. A big thank you to Paul Short and the team at CombiLift for helping us all to build it better. Visit them at combilift.com. Brave Control Solutions, where offsite manufacturing systems that do more than just improve productivity. They have a unique approach to industrialized construction, a lineup of flexible automation systems specifically designed for the construction industry, empowered by CAD to Fab, and turnkey solutions for 3D volumetric assembly, structural insulated panels, finished wall assemblies, MEP component processing, assembly, kitting, and storage. Learn more at thinkbrave.com. All right, again, we got to thank all of our sponsors. Thank you so much for everything that you do for us to keep it going and keep it real. And hope you're heading to World of Modular because we will be in Orlando, Florida next week at the World of Modular. So make sure you send us a note and let us know you're going to be there. We would love to connect with you. All right, without further ado, let's hop on with Anna and get into this conversation of delivering 3D printers with pickup trucks. I love this. This is going to be so much fun. Anna, thank you for joining us today.
Hello.
You know, I am super excited about this because we've talked about 3D printing before on the show. We've had other companies that do 3D printing on the show, but we have not had a company like yours on the show, and this is exciting. So before we get into the breaking news, before we get into what Apis Core is and how it does it, we want to know everything about you, Anna, from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we may have your mother on the show, and it could get quite embarrassing. But you only have 2 minutes to do it. The floor is yours.
Oh, yeah, absolutely. My mom would be happy, to tell all of the stories, what crazy things I was doing when I was as a kid.
I bet.
Selling some stuff from home. This is how I started, and my dad basically caught me and said, like, what are you doing? I was like, me and my sister were selling stuff. We're going to make money. He's like, stop, So, yeah, we have a lot of stories like that. So this is how my entrepreneurship started, But realistically, it's really started when I met my co-founder, Nick. And Nick, who's the inventor and CTO of Episcore, he really invented the breakthrough technology that we are all happy to share today. And that's something that construction companies really like because of the approach, how it was invented and reasoning behind inventing the technology. But I studied space physics. And before I met Nick, I was doing some of the, small entrepreneurship stuff. I was trying to find a way how to be part of something really big, right? And then finally, when I met Nick, that kind of like it clicked because he was doing already a company with the building CNC machinery and like all of the robots. So factories would basically come to him and say, we need to do this really particular technical task, but all of the CNC machines, they're so expensive, or we just can't find them. So he would come to the this factories and he would build really specialized CNC machinery for them. This is how I started picking up the knowledge about the robots and CNC machinery. And because of my experience, like my education in physics and basically STEM, that was pretty easy for me to pick it up. And so then we also got a very big construction project on Olympic Games in 2014. We had to design, build, and deploy 5,000 navigation signages for all of the millions of people coming to the Olympic Games. So we are like at 22 years old. We were responsible for all of the visitors from all over the world not to get lost, right? And we successfully did it. And so this is how we made our first money together, big money together. And this is how we saw how outdated construction industry was, right? And this is how we started thinking, okay, there has to be the room for automation and robots into the construction. And all of the really promising technology was construction 3D printing, but they all were using Gen 3 big printers. The idea was like, yeah, we have a CNC machine or like a desktop plastic printer. Let's just make it 1,000 times bigger so we can 3D print bigger things like houses. But we, like Nick and I, from our experience in the CNC machinery, we knew that it's not going to be scalable because we knew how hard it is to install this type of machinery. The bigger it comes, the more expensive and like harder it becomes to do. And then you need to install these Gen 3 machines on every new construction site. It just no way to do that. So this is how we created a Frank, reasoning from the mobility and compact sizes.
Yeah, I love it. And I'm just going to put this up here. We're going to get into the 3D printing and everything else with Frank. And Frank has a buddy named Gary, and we can't have a party without Gary, right? I mean, you got to have Frank and Gary. It's just the way this whole thing is going to work. But first, before we get into all of this, we have some breaking news as well. Why don't you tell us a little bit about what happened with one of the, if not the largest home builder in America?
Yeah, they actually the largest, right? So we're really happy to announce today that dear Horton made the strategic investment in us. And also we're going to work together on the multi-unit construction project with them and figure out the new designs and how to really successfully use this technology to figure out how to scale. So that was really a big thing for us because, having access to their experience and knowledge, that was really essential for us, even as we were discovering how we can work together, right? So, and for us, it's like, we want to make this thing big, and we want to provide this technology, our technology, to every home builder in the United States. And working with the building the relationships with the dear Horton and has access again to their expertise and all of the knowledge, that would be essential for us to, figure out how to make it big.
It's interesting to me because D.R. Horton is investing in a lot of R&D, investing in a lot of startup companies and new technology out there. They really are putting their best foot forward to see how they can build it better. And I'm super happy to hear that it was a good, investment with you guys, and looking forward to seeing what comes out of it. And I can tell you, as soon as you see Frank and Gary, you're going to get why they invested. I'm already kind of trying to get pole position for Pennsylvania, and I want all the rights in Pennsylvania. Okay, just letting you know. Hey, but in all seriousness, can you give us an overview on Episcore and what the mission is, for Frank and Gary in the 3D printing for our construction industry?
Yeah. So, we started this company, we founded this company because we wanted to provide a solution to home builders how to build faster, more productive, with the higher productivity, but more importantly, how to uh, not rely on the skilled labor, which is getting more and more expensive and harder to find. And again, came from our experience in that huge construction project, because it was so hard to find skilled labor to keep up with the schedule, so we can also keep up with the schedule for all of the other stuff. And so the same thing happens today with in the home builder industry. So the home builders, they can have like a 10 people working on site today, but there is no guarantee if all of these 10 people are going to be tomorrow on site. And maybe the entire construction can be delayed for like a 1 week, right? And then what actually happens is that all of this the next construction processes like electrical, mechanical, plumbing, that also get delayed, right? So today it's very hard to predict the budget and the timeline, and your cost is constantly like
Yeah.
differentiate. So this is how we started this, how we can provide the tool for the home builders to empower them to build more. We're not trying to compete with people, because there is so much work for robots and for people, and we still can keep up with the growing demand for houses.
Well, I mean, listen, we've been saying it for a long time on this show. How do we do more with less? And that's less workers, because that's what we have right now.
Yep.
And this is just another tool in the builder's tool belt to help us build more, better, faster, quicker, more sustainable, all this fun stuff. And we're going to get into
Yep.
this. And we do have a presentation to get into. You're going to share some things that you shared at the launch on the big stage at the International Builder Show. So I'm looking forward to talking about some of those things. But, before we hop into that, tell us a little bit, like what was the first rollout of this? How did you go and develop a robot? Walk us through how you got to where you are today. I'm really curious. Nobody
Yeah,
just sits at home and
absolutely.
builds a robot that, prints concrete.
Yeah. Yeah. So again, like the idea originated from the reasoning how to make or like invent the robot that would be very easy to transport, very compact and very easy to operate, because the construction, it's all about logistics, right?
Yeah.
So reasoning from that, the idea of Frank, and it's pure novelty. It's never existed before. It's a robot, new type of robot. So this is how we invented it. And of course, like we 3D printed first, a really ugly wall, right? But even that wall was already like in breaking news, because it's like the new design of the robot. We didn't have Gary back then. Gary, again, like it's our proprietary mixer and pump machine. So soon after, we 3D printed first prototype, like a yellow round house. That was just pure prototype, and we're like, okay, how we can build something more than wall, right? It was like, of course, really hard experience, but that worked, right? We tested everything. And then Dubai government, they saw that and like, oh wow, we really want to do the pilot project with this particular machine, because they were already familiar with the gantry printers. They were not really that satisfied, and they're like, we want to build something really big, and your machine can do that, right? So we 3D printed the big building, and I'm gonna show it right now if you
Perfect.
can allow it to me. Yeah. So this building, we 3D printed this big building. It's administrative building, officially Guinness World Record, and it still stays official Guinness World Record as the largest building ever 3D printed on Earth. And we use just single machine for that. So it's 6,400 square feet of living area, 2 stories. It's 31 feet tall. So 2-story building, but when you stand next to it, it actually like looks like 4-story building. And so that was really a huge milestone, not just for us, but for the entire industry, because now we really demonstrated that 3D printing technology for construction can be used to 3D print big building directly on site. Because before, companies 3D printed like walls or separate elements, they would bring it on site and assemble them together. So it's still like a modular type of construction.
Right.
It was just new way how to produce the panels and the elements of houses, but never really the big commercial building like that size was 3D printed on site. And after that experience, we created Gary. because we used standard plastering machine to 3D print this building. That was a nightmare. It was like, oh my God, but we survived. We did that. Every 2 hours we needed to clean the system, right? Because
Right.
the plastering machine, they are not invented for the high viscosity sticky materials, right? So then we created Gary because if we want to scale this technology, we also need to think holistically about everything, not just about the robot that prints funny layers, right? It also has to be the entire system.
So the system, when you were printing this building, for instance, is it much different today than when you did the world record building? And what year was that, by the way?
So for the Dubai, it was 2017 we started, and 2000 late 2018 we finished. But again, it was not just the walls; it was the entire project.
Yeah.
Huge research and development project. And back then, our Frank was a little bit bigger, and Frank didn't have the. Let me show it to you. It was not that mobile, right? We used crane to move Frank from one location to another location. This is the new Frank, right? So you see how mobile it is, and as long as you know how to play video games, you will be good to figure out how to move the robot. So right now it's Frank and Gary. They're kind of like a little tanks, right? Fully mobile. And again, this is something that we learned from Dubai, that just having the crane on the construction site can cost like $20,000 just to deliver that, right? It's like two concrete slabs for a residential house.
Play that again, if you don't mind. I want to so I think I went on to the next one there, but I think what's really cool about this is that's just going in the back of a regular toad, like a landscaper uses to deliver it. What are the weights? Are they really heavy?
Oh, so it's 1.5 metric tons for Frank, and 800 kgs for Gary. Okay. So it's basically, sorry, it's kgs, not pounds.
That's okay. Somebody out there can convert it and put it in the comments. That'd be great.
But in a nutshell, you can use standard Ford 250 or Dodge Ram 2500, and you will be fine to tow it. So this is what we use. We use Dodge Ram 2500. Here you can see it. This is the trailer, but the pickup truck is pulling the trailer.
Got it. So can you stop it right there? Hit pause. So on Frank there. So talk to me a little bit. How does it go higher and lower? I guess it has a hydraulic in the center. And how high can it go before it needs to be moved to another floor?
Yeah, this is here, for example, the full extent here.
Yeah. Okay.
So we have the lifting system in the Gary and in the Frank, and it can go up to 10.5 feet tall. It's from the concrete slab to the extruder. So when stationary, we can 3D print, the standard height of the single family story house. But we also can go higher if we put the Frank on the extension, right? Because again, Frank is pretty easy to, move around. Again, like using crane, for example. So we right now working on how to make this transition from first floor to second floor even easier. But even right now, you don't need to do anything. You already can 3D print 10 feet tall walls.
Right. I could see Frank actually going up and then hooking itself on and lifting itself up to the next floor. That's what I see. Just like you see these excavators on YouTube do that kind of stuff. Walk me through the project. So we got a project we're seeing right there. How does Frank, one, get the information? What kind of plans does it work with? Can I use Revit files?
You need to use AutoCAD, but basically the process is to design the house for our system. It's the same as you would design the house for concrete block construction. And this is something that we're also really proud of, that instead of reinventing the wall, we just mimic what already exists, concrete block wall. And that means that we reinforce it the same way. We can install the windows, doors, roof, all the same way. So in the phase when the architects and civil engineers creating the construction documents, that's standard process. We do not change anything there. And then once you have the construction documents ready and stamped, we use AutoCAD, and we also have our special plug-in, so we can quickly, convert the lines into the trajectory, basically how the frank should move. And then also our software, proprietary software that embedded into Gary. Actually, Gary controls, everything.
Right.
So Gary also has the software to say like a pump now, pump, stops now. Mary needs to send the material. So it's the three pieces actually. Again, Gary, Frank, and Mary. Mary is the bulk truck here to deliver the material on site. They all communicate together, right? So it's like enough material sent, not over pumping, not less pumping. So yeah, it's kind of like the choreography between them.
Yeah. So I'm trying to walk through this. All right. So we have the plans in Auto, in AutoCAD. We can bring those AutoCAD plans that are just taking a regular masonry wall and bringing it into the Apis Core app or the Apis Core system, right? Which then translates it into what needs to be built on site. How does now the robots on site? Does it have to be working on a level surface, or does it self-level when it's on site? Would be one question. And then two, let us know how Gary and Frank connect each other. And then how does Gary get the concrete on site like that?
Oh, yeah. All great questions. Thank you for asking that. So first, about the leveling. We do have the leveling system. It's also something that's embedded in the hardware and the software. So you bring the Frank on the site. And typically, concrete slabs, we need to have the concrete slab before we start printing the walls. Typically, concrete slab, it's pretty, even, like a flat, and should be very precise, but of course it's construction, right? So Frank has basically four kind of legs, it's four, cylinders here on the all corners. It comes to the side, then we start doing the leveling, and you actually don't see anything. So it's like you look at Frank and nothing happens, but you can see that each of these cylinders, they kind of like move up and down. That means that Frank is calculating how to position on the slab so everything gonna be straight. So that takes like 5 to 10 minutes. And again, it's like here, for example, we do the calibration for the new position. When Frank comes to the new location of the house, you see here, it's finished the first position of the house. Now we move it to another one. And it's actually just one person operating this, two other guys just making the video. And then you kind of like synchronize it in the software. So Frank could understand how to, synchronize the new section of a house with the already printed one. And the entire process takes like 25 minutes, even less, like 20 minutes. So we work on that as well. And about the material, so Mary, the bulk truck that I was just showing before, Mary holds the dry material, and it's we use our proprietary mixture for the 3D print concrete. It's very close to regular concrete, but not like a ready mix concrete, because the ready mix, it's basically the big puddle. You wouldn't be able to extrude layers, right? So to make it extrudable and pumpable and printable, we need to create, kind of like a tweak the formula. And our formula, it's cement, sand, and market available components that makes the material, 3D printable, like layers. It can be produced locally because cement and sand is available everywhere. And Mary get filled with all of the dry material already blended, right? And then it comes to the construction site. We quickly connect Mary to Gary and Frank, just, connecting hoses. It's plug and play solution. That takes maybe like 15 minutes. And then dry material from Mary, Mary sent dry material to Gary. Gary mixed it with water, with already, preset percentage of water that you need, that for your recipe that work. And then Gary immediately sent the already mixed concrete to Frank, and Frank printed. So this is basically how everything works. So the material, again, comes to the site as a dry powder and mixed with water at the moment when you're ready to print.
So you're just doing your own ready mix basically on site as needed, and you're only as slow as you're able. It doesn't slow you down. You're not waiting for a truck. You have all the materials you need, is what I'm getting to. And you just keep going and going and going. Awesome. Some of these homes, like I'm looking at 2,200 square feet. How long does it take to print a house?
Yeah, great question. That's, again, like it depends on the floor plan and all of the details. But generally speaking, to 3D print 2,200 square feet house, one story, it can take from 40 to 60 hours of machine time. But let's say you can work only 8 hours per day, because some of the counties they do not allow to work like in the during the nights. So conservatively speaking, it can take about a week to 3D print the walls for the 2,200 square feet house.
Wow. And it can work 24 hours if we were able to, and the code didn't stop us, is what I'm hearing.
Oh yeah, exactly. Yeah, you can work 24 hours, and also you can synchronize two francs to work together, right? So in this case, you can actually like complete the house within like a couple of days.
Got it. So when this is printing, just getting back to it, what about any bracing, any rebar, anything like the window ledgers that need to be put in? I see some, the pressure treated lumber on those windows, that we were looking at on the. How does that happen? You just need one person running the robot and one person placing these things, or does the robot place those as well?
Not yet. So
Okay.
right now we 3D print the walls.
Yeah.
And so then once you 3D printed the walls, you install the rebar, and you also fill, let's say, every fourth cavity with the grout. This is how you get the structural reinforcement. And again, we have the new process, but the walls are the same. It's concrete block walls. This is what it's like comparable to. And then you install the roof the same way as you would install for the concrete block house, and the windows the same way. So basically, once we are ready to install the window, we install the wood frame already, prefabricated before. And right now our team is doing this, right? So, but the one person needed to operate the frank, and a couple of people need to, to do this, like to install the reinforcement, the windows, doors, and everything like that. Once we install the wood frame for the windows, we continue printing on top of it, and the wood frame just living in the house. We are working right now how to make this process even like better and more productive.
Yeah.
But even today, everything that used in conventional construction, we can do the same.
In the 3D printing construction, right? Let's talk about the materials, right? We have our traditional concrete material that you're mixing on site. Are you looking at applications to be able to use materials from around the world? So this can be used, let's say, in the Sahara Desert, or wherever the case may be. Even Saudi, did you use traditional concrete, or were you able to take a proprietary mix of their sand they already have on site?
Yeah, great question. So the formula that we use, we have to, tweak it or adapt it to the local sand and cement. Because even sand, we can think like, oh, sand is like the same everywhere. But actually, like even from one mining location to another mining location, sand can have a different physical properties. It is not something that ruins the idea of our formula completely. We just need to, fine tune it a little bit. And we can use any, sand in Sahara, in Africa, in any part of the world, right?
Yeah.
And we understand that the concrete-like material that we use today, it's not the only material that we can use. We also have the long-term vision and plan how to use eco-friendly materials, and we're really interested in geopolymer material. Geopolymer material is not plastic. It's basically concrete, but without cement as a binder. And the good thing about the geopolymers is it's been already used in the industry. It's not something like a completely new. Airports in Australia and Europe was built using geopolymer, and it's way more stronger, very fire resistant, and just superior material. We already tested it in the past, so we have planned to transition to that as well. And ideally have like a multiple type of materials, because somebody would still like to use concrete. Some companies would like to use geopolymer. Some companies maybe you're going to use completely different concrete with the different, maybe like they want to build bunkers, for example. So they will need to have material with a 10,000 PSI. And we know how to do this. It's just more expensive. So the idea is to provide a variety of different materials to really meet every single, like most of the needs in the construction industry.
That's great. That is great. So let's walk through some of the, safety and, of these robots on site, and how do you ensure, the reliability of these robots? Any new technology, I'm sure, has its ups and downs, but walk us through, one, how safe are they with people around, and two, because all the kids in the neighborhood are going to want to come see the robot, right?
Yep. Yep.
So walk us through that and then walk us through, the maintenance on them.
Mm-hmm. Well, the safety of the machinery, it was something that we were thinking in the first days, right? Because you may know that in the world of the industrial machinery, let's say the industrial robots that installed in factories and build the machines, build the cars, right? Like automation of the processes of manufacturing. They require a lot of safety measures, like the special laser the curtains, for example, because if person coming in the area where the robotic arm works, robotic arm will not recognize it. And there are a lot of, sad stories when the people was just killed by machinery, right? So we understand that in the construction site, we will not be able to, put the fence and say do not come in the area where the Frank is working, because it's construction environment. It's pretty, busy. A lot of people all the time need to be in the construction site. So we incorporated a lot of safety measures in the Frank. And in fact, for example, Frank can 3D print walls, but if person, for example, didn't see the Frank, and Frank slightly, touch the person, it stops, right? So it's not going to go further and smash somebody into the wall. And in fact, we had a lot of funny stories, because we didn't want to stop the printing process right on the site, but sometimes our team can didn't see the Frank coming, so it was a lot of stops because all of the safety stuff. So we already tested it. So Frank is actually pretty reliable and very human friendly, I would say. So he's not going to kill anybody on the construction site.
Well, and that's exactly it. We don't want anybody getting killed on a construction site. No, and that's great that technology is built into it. How long does it take to learn how to use Frank? And how do you deploy this on a large scale and train those people on how to use Frank and Gary? I keep forgetting Gary. Gary, welcome back to the party. Sorry.
Yeah. So that was also part of how to make this technology very easy to use by anyone, right? Because even if you have great technology, but it's really hard for people to pick it up and how to use it, that's going to be the problem, how to scale, right? So right now, again, as I said, if you know how to use AutoCAD, if you're familiar with the joysticks and video games, and you have some, technology experience with whether a small 3D printers for plastic or something like that, it will be very easy for you to pick it up, how to operate the printer. We even have online courses. We call it Episcore University, when we tell more about the technology in general, and we're going to grow Episcore University. So later on, it's going to be more locations where printer operators can come and get certified to operate our printers. So in this case, we're not all the time, depends on our team. For example, you can go on our website and say, here in San Francisco or in Florida, in Orlando, these people are certified to operate the Frank, right? Because they already went through our training. And that's basically how we foresee it to scale this and get more people involved in the construction industry with our really easy to use technology.
Love it. All right. So listen, if you're just joining us, let us know where you're watching from. I hope you're enjoying the conversation. And if you're interested in learning more about 3D printing on Dave Cooper Live, give us a thumbs up. This is a modern method of construction. Is it here to stay? We always want your thoughts and comments. And Anna would love to have your feedback as well. As any new emerging technology and growing anything, good feedback, bad feedback, we love it all because it helps us all to build us better. So just put your comments in the comment section. And if you're watching this after the live show, we'll get to those questions and answers as well later in the week. But don't be afraid. Somebody will respond to you. All right, Anna. So where are we going from here? Tell me what the future looks like for Episcore. How fast are we growing? How many projects do you have? How much interest do you have out there? Where are we going?
Yeah. So our mission and our goal is to really empower home builders with our technology so they can use it as a tool to build faster. And, instead of 50 houses per year, they can build 100 houses per year, right? So we really want to uh, get as many printers out there as possible and get as many home builders to use it as possible. So we foresee that like we need to have like hundreds of ranks within the next 5 years deployed within the United States with the home builders. This is our plan. And in addition to that, we are not really the just, oh, this is our robots, use it and figure out, like all of the construction solutions. We think about this really holistically. We work on the construction techniques and solutions, how to integrate this technology into existing processes and supply chain, right? So for example, we created our proprietary mix design. We created the walls that can pass the inspection and the building permitting process. So we thought about everything, even Mary, the bulk truck, that also how to not to have people on site just to load like a 40,000 pounds of 3D print material, right? It's not scalable. So the holistic approach is what we're really thinking about. So we're going to grow as a technology company to provide, again, like the best solution possible for the home builders. And yeah, so what was the another question?
Well, you know what? I tell you what, I think the question everybody's going to ask, how much does it cost to get involved and use one of these on my job sites? I mean, is it going to be where I have to buy the machine? Can I lease the machine? Because, and I'm sorry, I left Mary out, right? We got Frank, Gary, and Mary. So
Yeah.
how do I get Frank, Gary, and Mary? And will it become more and more affordable as the technology grows and as your footprint grows? How do I get involved? How do I use your product?
Oh yeah. So right now we're looking for early adopters, right? So the companies who really want to be in the front line of the innovative technologies and help us, as you said, with the feedback and collaborative work to figure out how to improve all of the processes and get it better and better. So our business model is to actually renting out the printers and supply our 3D print material. And so the reason is that we want to make sure that the end product, the houses, the walls, going to be safe and sound, built according to the building codes, and because we know how the material is created and we know the end product, the walls itself. So if you want to be involved in that, just reach us out on our website and we have multiple options how we can start working together. But again, like we want to make sure that we're really good fit right now as we are penetrating the market, right? Because it's like a success of our early adopters, it's our success. But yeah, for the scalability, we want to have the machines as available as possible. So we foresee that it's going to be short-term and long-term rental of the equipment.
Anna, did I leave anything out of today's conversation that you want to make sure everybody knows about Apis Core or yourself personally?
Oh gosh, I think we discussed a lot of things, and I'm really happy to have the opportunity to tell more about like the how we different and what is the actual like end game of the construction 3D printing, because we see a lot of excitement, right? Like a lot of houses built, but construction, it's not something that happens out of the excitement. All of the numbers, like it costs, it's really has to be thoroughly, worked out. So this is why we're also happy to start our relationships with the DR Horton, because again, like with their experience and knowledge and all of the supply chain and everything like that, they can significantly help us to figure out how to make this technology available for everyone sooner.
Love it. Let's go to a couple comments here real quick, and then we're going to wrap it up. All right, Tim Sims in the house. What's up, Tim? Congratulations, Anna and team. This is good for the industry. Great to see home builders like DR Horton putting capital to work like this instead of just stock buybacks and dividends like many do. Absolutely.
Yeah, thank you so much. Yeah, and this is also one of the things when we really appreciate working with the DR Horton, because I think we showed each other that we really want to like very fruitfully work together. It's not something like we just want to have a quick exit or something like that. It's really something that we really appreciate.
You're passionate about it and you want to see it blossom, right?
Yeah,
That's
exactly.
I'm picking it up the whole way through. You can tell you're loving what you're doing. So, and come on, I mean, you took the Olympics to the next level and nobody got lost. How could this be hard?
Yeah.
Greg Ugaldi says, and by the way, if you don't know Greg, he is the past chair of the National Association of Home Builders. You were just at the International Builders Show. He is the top guy. So at that show and for the NAHB. Well, Anna, have you tape a DR Horton delivery from Gary and Frank? Don't forget Mary.
Yeah. But Mary, she is pretty like an independent woman, you know. She can be easily brought to the construction site.
I love it. Oh, here, Greg put it out there. He said, along comes Mary. The association pulls everything together. Love it. All right, let's go to this last comment here. Henry Mickelberg. So I'm Horton, and I need to make an informed value prop decision to prove the pros and cons of the solution versus others, which requires like for like comparisons. What methodology are you instigating to do this? That's a good question.
How to like a pros and cons. So again, like I can't really, you know, comment on a lot of stuff that we're going to do with the DR Horton. But again, like the multi construction projects that we're going to work together on, it's part of this as well, right? So to not just figure out how it's different, but also figure out the way how we can successfully, you know, scale and make the process really efficient by using our technology.
Henry, thank you for comment. Hey, Joel, better late than never, man. Good to see you advancing prefab. Hey, we'll be in Florida next week. Joel, hit us up if you're going to be around Orlando, World of Modular. No worries. We'll forgive you for joining late. All right, Anna, thank you so much for everything. I think this is great. I'm really happy for you. You did an amazing job at the launch at the International Builders Show. You had about 1,000 people in the audience when you were on stage. It was packed. It was a big stage, right?
Yeah, and I was first.
You were first. You were definitely first. But hey, you got it out of the way, which I think is great. And for all of you out there, listen, if you want to learn more about 3D printing, if you'd like to see more 3D printing technology on the Dave Cooper Live Show, let us know that as well. If you don't want to see more, let us know that as well. But as this technology advances and we end up with Frank, Gary, and the independent woman, Mary, on our show, I think we only have one way to go, and that's up. This is getting bigger and better, and I see this being used more and more. So, Anna, thank you for joining us today.
Yeah, thank you so much. That was a pleasure. Thank you all.
Awesome. Awesome. All right. Don't go anywhere. And I'll come back to you at the end of the show. But for the rest of you out there, we can't do this without our sponsors. So make sure you say thank you to these sponsors as well. Thanks for watching. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.